Okay, so I'm going to break up Monday's lesson a little bit. Instead of having like a marathon lesson on Monday, let's just get started with it. We have 3 more graphs to talk about. One of them being tangent, which I'm going to talk about today. And then 2 of them on Monday, the secant and cosecant graphs. Okay? So, go to wherever you need to go in your notebook. I am going to give you another half sheet of blue paper for how to graph a tangent graph. So if that determines how and where you write on your piece of paper, just there's your warning. Okay. But before I hand out this blue piece of paper, I want to take a couple moments and come up with the parent graph for the tangent function. Okay. So I have my unit circle up here. Okay. All right, what is true about the tangent at 0? It is 0. Okay. Now there's a lot of different tangent ratios we could collect. All right, but let's go for some easy ones, right? What's the tangent of pi over 4? The tangent of pi over 4 is 1. Okay. What happens when we get to the tangent of pi over 2? It's undefined. So graphically, what do we put when we have an undefined value? An asymptote. So at pi over 2, we have a vertical asymptote. All right, now I'm kind of curious, like, what happens over here? Like, I have this asymptote, and we could keep going with values over and over and over and over again. But let's finish off this side over here. So if we rotate in the negative direction, if we call this negative pi over 4, what is our tangent ratio? Oh, -1. And what is our tangent ratio for negative pi over 2? Also undefined. And we know that our asymptotes mean that our curve needs to approach and never touch. So if you kind of imagine the curvature of a cubic function, this is not a cubic function, but it curves a little bit like it, okay, stuck in between 2 asymptotes. And I don't really have enough room to capture it up there, but what's happening is we have asymptotes over and over and over again with these curves in between. Okay, so this happens over and over and over and over. Now, am I going to make you graph all of this? I am only going to have you graph 1 full period. Okay? Now, look at our parent graph. What is 1 full period? We begin at negative pi over 2, which I think my negative got lost somewhere. And we end at pi over 2. What is that length? Okay. The period of a tangent graph, at least for the parent function, is pi. That is different. Okay, that is different. Also, is it bouncing in between 2 values? No. So there is no amplitude. Okay, we're going to identify A but it's not the amplitude. It's just going to help us with the frame. Okay, I am going to hand out so on your blue sheet, it says y equals a tangent of bx minus c plus d. So that looks the same as when we had sine or cosine. All right. Now, the starting point is still going to be the same. However, in a tangent graph, your starting point is going to be in the middle of your frame. You can see that on those pictures down below. Okay, that is different from sine, cosine, secant, and cosecant. The tangent starting point is in the middle of the frame. Okay, the absolute value of A is not amplitude because tangent doesn't have amplitude, but we're still going to use it the same in order to find the height of the frame. So we're still going to go up and down that amplitude for our frame. We're just not going to call it amplitude. Okay. Since our tangent parent graph had a period of pi, when we calculate any sort of horizontal stretch or shrink, the new period is going to be pi over b. Okay. So we'll know how long to make our rectangle based on pi over b. Now there's the same two methods that we could use here, except half of the period needs to go to the right and half of the period needs to go to the left of our starting point. So if you liked method 1 using the midpoints, then we're still going to have to split our period in half. Half of it goes to the right, half of it goes to the left, and then we can split them into midpoints. Okay? If you want to use method 2, then you're still going to split the period in 4s, but you would add a fourth of the period twice to the right and a fourth of the period twice to the left. So you pick whatever works for you. Okay? And then we have 3 critical points and 2 asymptotes. So what's going to happen if you go down to the bottom of that blue piece of paper where it says tangent with a positive A, the edges of your frame are going to tell you where your asymptotes are going to go. The edges of your frame tells you where your asymptotes will go. Then the quarter marks tell you where your points are. No matter what, it's going to go through the starting point. And then if it's a positive graph, you're going to use the quarter mark at the top of the frame on the right, and then the quarter mark at the bottom of your frame on your left. If we have a tangent graph that has a negative A, the only thing that changes, so here's your starting point, is the direction. So we still have the edges of our frame for our asymptote, but now we want the graph to fall. So up here would be, on the left would be the top point, on the right would be the bottom point. And our graph would fall while still approaching the asymptotes. So use that blue piece of paper for reference. All of the steps are listed for you. Okay? There's your two pictures that you need to model. Okay. I think with 7 minutes we can do one example. Okay? My suggestion to you, technically you don't have homework until Monday, but what I would do if I were you, I would open that 4.6 book assignment and do the tangent problems this weekend. Anything with secant or cosecant, please skip. I haven't taught you how to do that. But do the tangent problems from your homework assignment. Okay? All right, so here's our one example. Y equals 2 tangent of x plus 3. All right, do not identify amplitude, only identify A to be 2. That's going to tell us how tall to make the frame. Okay. Remember the period is now pi divided by B, but since B is 1, our period will remain pi. Do you see anything added or subtracted inside? All right. So for our starting point, there is no C value, but the D value is 3. So here's our starting point, 0, 3. If we go up A, where are we vertically? What?
0, 5.
We're at 5. And if we go down 2? Okay. So our frame vertically stretches from 1 to 5. Okay. Now this is an x-coordinate of 0, and our period is pi. So half of our period is pi over 2. So we want to go pi over 2 to the right and pi over 2 to the left, so that total we have the period of pi. What's halfway between 0 and pi over 2? Pi over 4. Halfway between 0 and negative pi over 2? Negative pi over 4. Okay. If you wanted to add a fourth of the period 2 times to the right and 2 times to the left, we get to the same place. So then, whatever the edge of your frame is, make dotted lines on them, and those are your asymptotes that, yes, I expect you to label.
So the asymptotes is just the edge of the period?
Yep. So basically, you just extend that edge. And then since this is a positive tangent graph, we want it to rise going through the starting point, and then the edge of the frame tells you where to make those other 2 points. So since we had that vertical stretch, this coordinate is at pi over 4, 5. And this coordinate is at negative pi over 4, 1. Ta-da! We did it. Also, fun thing, I will never ask you for the domain. Your domain is broken up by an infinite number of asymptotes. I'm not going to ask you to express that. Okay? However, what will your range always be? All real numbers. It stretches from top to bottom. It never ends. Madeline, what do you think, question?
Where's the positive for the edge of the line?
Since our period was pi, we want half of it to the right and half of it to the left because we're in the middle. So I split it in half and did it that way.